Hello community, finally a Mistral AI European model. Let's do some logic test. And you know this test, I test everything from the latest model here, also to the smallest model 8B. I test an Opus, I test a Sonnet, whatever. So I have my personal test and we look here at Magistral and they tell us, yeah, we have two variants. Magistral small at 24B, an open source model. This is great. And of course, then we have the big brother Magistral MEDIUM. Now, where do we find it? We go directly here. We see here a version of Magistral MEDIUM is available on the chat with Mistral AI directly, and this is where we're gonna go. Now, if we have a short look at the technical paper here of Mistral AI, we see that Magistral MEDIUM was especially trained for reasoning. And you know, I'm interested in reasoning. And it was done with reinforcement learning alone, so I say absolutely beautiful. If we look at the paper, and you are an expert here, if you are a subscriber of my channel, and you see that your PE loss function here has this beautiful modification for clip higher, and you immediately remember because just a week ago, we talked about in my video Ignite AI entropy collapse. If we go here with a classical GRPO, we have the entropy collapse. And we talked about GRPO with a clip higher, and we saw, hey, this is really an efficient measure to stop the entropy collapse if you analyze the entropy dynamics. So you find this here, this is the thumbnail to my video. And they also have here in Mistral AI in the technical paper, they have a particular analysis of the entropy targeting. So nice. So this goes absolutely in the correct direction. This is with current research. If you want to learn more about this, I have a second video on the token entropy where I explain in further detail. So for me, this looks like a real interesting architecture and on RL training. And suddenly we don't have only two hotspots in the world, here on the west coast of the US with Google, OpenAI and Anthropic, and China with DeepSeek and Cuba, and those are the models that I know. And now suddenly we have here a little startup here in France, close to Paris, and they tell us, yes, we have a model. So finally the European Union is here also on the map. And I just noticed looking at this, hey, what about the other beautiful nations here on our planet? I don't know, what about India? I'm sure India has a beautiful startup company in AI. I know nothing. So, hey, if you know something, leave a comment. What about Australia? What about South America? Hey, help me to learn. Comment, hey, we have this AI system. This is our national AI system. This is here in our national language. This is here representing our culture, our, I don't know, whatever you have. I would like to learn more. But you know what? Let's start the test. Let's sit here in a new car. You remember the smell of a new car, and let's start the engine because now we are gonna test it. And here we are live at the Mistral AI platforms. No agent, no libraries, no connection, no nothing. I am not at Pro. I did not upgrade here. Thinking, okay, pure thinking. Disable the tools. Let's have it disabled. Tools. Code interpreter. No, I want to have a pure causal reasoning by the LLM. No image generation, no web search, no nothing. So let's input here, and we have the first test here on Magistral MEDIUM. And what you see is we have the thinking process. Okay, this is nice. It is not like OpenAI, like here the 04 mini that we tested, where you have just nothing, blank, dark. There's no information about the reasoning process by OpenAI. We are completely left in the dark. And I like if we have a model where you can see the reasoning process of the model. You remember with Gemini, we used to see the reasoning steps in detail, like we see here, and then Gemini, Google, for whatever reason, decided to just give us generic reasoning information. Now I'm analyzing this particular problem. Now I'm deep into analyzing the next problem. So, nice. I like it if I see here. It is currently analyzing here, as you see, the move. We have a test. We are in an elevator. We're going to floor from 0 to 35. And we have 5 different buttons we can press. This is the cool complexity of the test. We have to stay within certain energy limits. And we have a master key card and 2, if you want, a red code and a blue code. But this could also be just a distraction. Very simple, a linear two-dimensional problem here. Go here from 0 to 35. You have 5 button presses that each button does something else. find the combination for the shortest path. It is the simplest problem you can imagine here in a logic test. And as you see, I deactivated here the code sequence, so no tool use. This is here if you want the original intelligence of the LLM alone without any tool use. What you see, we have just now that it's segmented the topic. It's not analyzing here from 0 to 35, but it broke it down in intervals, no? You see it's now trying to find sequences that it can stack upon each other to find a valuable solution. Now, I designed a test that it is not easy at all. And you know from my other test, we have the perfect solution is a 6-button press solution. This is the shortest solution. And as you see, we already are at 6 moves. This is impressive. For the very first reasoning model by Mistral AI to arrive within, 2-3 minutes of reasoning already at a 6-button solution for this particular test is absolutely impressive. So let's see what's happening. I like to read here, so not helpful. Okay, we have a self-reflection. Okay, it's trying here other. Okay, no, this is not it. Let me verify this. A self-reflection, a self-verification process. It analyzes here different variation of the different steps. Okay. So you see it tries now to go here from the floor 27 just to the floor 35. It tries here on a reduced complexity task. It separated this into subtasks that are easier to solve. But in total, I built here this particular test that you cannot absolutely have here a reduction of the complexity at one point here. You have to analyze here the complete sequence variation and multiplicities, otherwise you fail. So you are here live with me. I don't modify anything. This is the real time. I see this on my screen. And as you see, it is now trying to find a solution that is shorter than 6 button presses on the elevators, which is interesting because, of course, the system doesn't know. We know that it already found here the shortest path solution. Oh yeah, final optimal path. 6 moves. Okay. Now it said, okay, I'm satisfied. I tried everything else. 6 moves seems to be the best solution, the final solution. We are still in the reasoning process, as you can see. Total move 6, verification of optimality. This is nice. We have an auto verification built into the system. And I love to see really what is going on, the single steps. This is a transparent reasoning that I prefer over Google's, yes, I'm into the problem, or OpenAI is just giving us a dark blank screen and coming up after 10 minutes and saying, hey, I found something. I want to see the source. I want to understand. Because if you are, for example, in medical, you really want to understand, have all the parameters been investigated and not just given an answer. We have no idea about transparency and verification. So here we have now a final answer and it's now generated. This is more, a more shiny white is now the real answer. Okay. Oh, okay. I'm live. You see what I see. Final state. Okay. Master keycard, yes. Blue card, no. Red code, no. This is the optimal path. This is the correct answer. We know this from our other tests. Okay. So we have it as a list. Hey, now I get a table. Hey, this is nice. So you see here each single move. You start from a button press, the current floor, the new floor, the energy change, and some particular notes on the gadgets we collect, and goal reached. This is the most efficient path. This sought for 5 minutes and 17 seconds. This is impressive for the first reasoning, dedicated reasoning process here. This is nice. I'm surprised. I did not expect this. I'm gonna tell you here, honestly, I expected here we are not gonna find here the perfect solution in the first run. Okay, absolutely amazing. You see the solution AB, AB, AB. You know, I like inherent symmetries in the way I design my test. but also here in the end, in the result. Now we activate tool use. We activate a code interpreter. No, not 10 speed, no. So let's see. I do now identical test with a Python tool use. I say code, Python solution, execute the code sequence to find the solution and maybe even verify your answer now. Let's see if we have multiple answers. Let's have a look. So as you can see, the system starts, state management, evaluate the path, and code implementation. A high-level structure of how we might implement this in code. Beautiful. I'm just watching here in real time with you together. Okay, yes. So it's just taking here my linguistic complexity, and it is trying to write code based on this. If you see, it's a simple. If this happens and this happens, then do the following. If something else happens, do the following. Yeah, it identified as a BFS methodology. Beautiful. This is the correct way, the correct solution path. Code selection, given this complexity. Code implementation for simplification. So we're gonna write now the same code again. Wait a minute. We just had this code, no? I did not pay absolute attention now to the code sequence in detail, but this looks a very similar code detail. Why do we do this again? This is interesting. BFS setup. Yeah, we had the BFS setup. So what is happening currently? Try all the bottoms, all the sequences, exactly, shortest path sequence. Let's execute this code and check our manual path, and we start again with the code. This is interesting. Why? Handle EPC. Okay. So for the moment, currently, I don't know what's happening, why we write now this for the third consecutive time. Because to me, the code looks rather similar in the structure. But I would have to stop here and have a look and compare it in detail. I don't want to stop by generating the answer. We'll implement a BFS algorithm. This is the correct way. Explore all states. Here's how we can do it. And we're writing the code again. Why do we write the code? There is a little difference. Oh, okay, this is not interesting. I think I spotted a new sequence. I'm not sure. Please help me. Is this the identical code? What is happening currently? I just let it run through. Let's run this running code interpreter. Oh, so let's run this code to verify our manual solution, and we have now the code interpreter in the background. Beautiful. We have tool use somewhere as a Python environment, and we are now executing the code. Now, you see, if we know a mathematical method like BFS that is here a valid solution, and BFS is now, I don't know, for 50, 100 years, so this is a standard solution, and we have on the internet, on any GitHub, I guess we have 1000 GitHubs where this is implemented, so no problem at all to find here the solution. And yeah, AB, AB, AB. Absolutely correct. Beautiful. So we have found a result with code, with tool use. AB, 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 yes. 6 presses from 0 to floor 35. This is the optimal path. Sort for 1 minute 55 seconds. And now we only have one code sequence. What happened to the other code sequences? Okay. I mean, absolutely beautiful. The code output is correct. It did the correct code. It arrived at the correct execution. We have the identical result. It worked great, amazingly. Okay, these are my button presses. AB, AB, AB. Yes, perfect symmetry. You see, this is my hint that with all my tests, I always build in a symmetry. We have the code interpreter running. But I ask, hey, why the multiple code sequences? What happened? This is the first time I run this, so I want to understand what happened. Huh? Why you wrote the code segment 4 times during the sort process. Any particular reason for this? And the system is thinking. Beautiful. It's a reasoning model. I love it. Still thinking. Were written multiple times during the sort to refine and correct the logic based on the feedback and deeper understanding of the problem rules. Ah, we had an initial draft We identified issue with the draft. We were not fully implemented or correctly handled. The prompt I revisited and refined to handling. And then we had a refinement, and then we had the final code. Okay. Can I see the reasoning? Yeah. You see the reasoning, there's the information I'm looking for. Okay, it optimized the code. It found during the code writing that it could optimize the code because the answer, as you see here in the bright white, are just 3 lines. You know, this is like OpenAI. It just gives you 3 lines, but I want to see the reasoning process. So for this behavior alone, you get a thumbs up, my little Mistral AI model. This is beautiful. I like this. Now, you know, we have a second test, and the second test is now more than a year old. We activate now the pure thinking mode. Let's go with this thinking mode. You find this test in my other video. It is a simple table. We have here 7 times 4 matrix where you have to find the solution to. So this is pure causal reasoning. So now with the activated thinking mode, so let's see this. I deactivated the code solution that would find it maybe immediately because I just want to see here, especially now the reasoning process on a new model. I want to smell here this, you know, the new car. I want to see what is this new model capable of doing? What is the reasoning process? Because normally when we run through, I just copy the complete reasoning process and I ask another AI to analyze this reasoning process for structure and strategy. But for the moment, we just let it run here in real time. And you see it's going through all the clues. We have 15 clues plus some complementary complexity clues, so 7 additional ones. So it is quite interesting to see, to go through all possible combinations here. But honestly, I do not expect that the system gets it here the very first time, because there are only a few LLMs, reasoning models in particular, that could do this here on the first run. And the new R1 is one of those, and the O3 by OpenAI is another model that managed this. So we have now, okay, alternative assignment. So it's looking at a particular port at a subsequence. It's trying to find not only one solution, but multiple alternative solutions. And then it's going to the next step in the sequence. Hey, we already are close to come here up with a final assignment. This looks interesting. Artifacts, yeah. The familiars. Okay, I'm generating an answer. Oh, this was fast. Oh no, we are still thinking. Now here, we're still thinking. No, this is not the answer. We're still in the reasoning process. Okay. You see it is fighting because here my additional complexity clues, they're the next level of a complexity. So it's fighting with the highest level of complexity. Okay. This is good. The system should go here to its absolute limits. Alternative complexity assignments. Yes. Okay. On the remaining complexity. So, hey, we have a final answer. This is it. Interesting. Oh, do you see? We have multiple twos. This is not okay. I say complexity levels are unique and range from 1 to 7. This is now a little bit of cheating from my side, because this hint should have not been possible, because I think in the original instruction I said the complexity ratings should be unique. So to have multiple twos is a sign. Okay, but so, okay, I have to give it a hint. It came up with a solution and I immediately saw there are multiple twos here in the complexity rating, which is not okay from the structure here. So let's see if now with this hint, the system is now able to find a solution. I've given not any part of any solution. I just say, hey, this is not acceptable if you have identical entries here multiple times. Find here unique solution to all the elements. And as you can see, it is trying here to go, wait a minute. But wait, earlier we had, yes, complexity assignments. Now we have from 1 to 7. Nice. Okay, so it needed this little hint from my side. Now it correct. Everything checks out. Okay, we have all the elements. Yes, everything is available. Let's click on this. Yeah, this is now a unique solution. Final answer based on the given clues. Yep. Compare this with DeepSeek R10528. Absolutely interesting. It looks like this is the absolute identical. Look, on the left side you have R1, and on the right side you have our new Mistral. It is identical. Impressive. And now, as always, I say verify all your elements of your final answer, because I want to see if during the verification process, it discovers here any problems, or it says, hey, you know what? I found another solution. But as you can see, we have here green checkbox, green checkbox, green checkbox. Yes, we have 15 green checkboxes. And now the complexity I'm missing. No additional complexity clues. Yeah. Check. 7 green boxes. Everything is satisfied. Verification done. This is an absolute impressive performance by the new Magistral MEDIUM. This is it. This is the correct answer. This is the identical answer to R10528. This is impressive. And now I ask, oh, message limit reached. So this was the free test. And I have to say, thumbs up, absolute positive impression. It has solved tests that also O3 solved correctly and R10528 solved in the correct way. Mistral AI, impressive performance.